It's 10 o'clock, so let me start. First, let me remind everybody that if anybody has, I know I speak rather loudly. Is it too loud? Or is it fine? I know I speak rather quickly. But if anybody has any questions, please feel free to raise your hand and we'll stop and attend to the question. By the same token, I'm going to make it a point to go sit in the bench just straight out there after class. If anybody needs to talk to me, I'm happy to address any questions or anything that you want to talk to me. And of course, you can send me an email anytime to arrange for a meeting in my office or via Zoom. So please, questions, if you want to consider archaeology, anthropology as a career, anything you want to discuss, I'm more than happy to do so. Let's do so either in class out there or at mutually convenient time. But feel free to do that. It's something that I certainly relish and I very much am happy to do. When the last class ended, we were exploring what made Homo erectus different from what had come before. And I said that the first thing that strikes you, that literally hits you in the face, is the tremendous differential in sexual dimorphism that exists between erectus and both the Australopithecines and Homo habilis. And I suggested very briefly that this may have to do with a significant behavioral change and a transition from harem-like social structures to pair-bonded societies. That's a subject that is a rather profound one. It's a hypothesis, not a fact, that is indeed what we're looking at. It's the sort of thing, it's a really good hypothesis to use as a subject of a doctoral dissertation. And I want to explore it in a little bit more detail today. But let me continue, before we do that, continue with the main differences between erectus and its immediate predecessors. Because it all pertains to this question of what is human? Which ones of these are human ancestors? A question which, if you stop 10 biological anthropologists out there and ask, you will probably get 9 different answers. It's not a question that is easily, some would argue that only Homo sapiens sapiens are humans. Others would say that, it goes all the way back to erectus. Others would say that it goes to habilis, and others would say that some of the Australopithecines are in direct line of descendants to us. So it's not a subject that is easily, that can be answered. It all depends on what you're focusing on. It all depends on how you define it. And depending on your definition, you will get an entirely different answer. That would make, incidentally, an excellent question for an exam for this class. What is human and which human ancestors belong to that category? And please explain your answers. And no matter what you answer, if you defend it, it's correct, because literally each one of these can be defended. So there's no consensus on this, is the point I'm trying to make. It all depends on your definition. It all depends on what you choose to emphasize. But one of the most obvious things that strikes anybody looking at the hominid ancestors is that erectus is the first one that actually makes it out of Africa. And that is a big, big deal. The history of humanity until erectus was the history of humanity in Africa. The history of humanity after erectus is the history of humanity in the old world. The history of humanity later on, in the New World, and many of the Pacific Islands were not conquered until much later, and that was only done, of course, not by erectus, but by Homo sapiens sapiens. And we'll come to that a little bit later on. But in a sense, the fact that erectus is the first hominid ancestor, a potential hominid ancestor to leave Africa, is a really, really big deal. And then that raises the question, what exactly was there about erectus that Leaving Africa, it entails a significant amount of movement over land and movement across different climatic zones. So it entails the ability to quickly and rapidly adapt to new environments, something that can only be done by means of technological achievements. So essentially, noting that Erectus is the first potential hominid ancestor to leave Africa raises the question, what technologies, what cognitive capabilities did Erectus have that others did not have that allowed it to be so successful? Is it leaving Africa? Is it a push thing in which essentially it's leaving Africa out of its own volition, seeking greener pastures, so to say? Or is it being pushed out of Africa because of climatic change or other pernicious factors that impel the movement elsewhere? We don't know the answer to those questions. In order to know the answer to those questions, you would have to be able to have very, very, very precise chronologies and be able to correlate what's happening in terms of climatic change and what's happening in terms of a biological and social change in these early hominids. And our chronologies are simply not precise enough. All we can do is hypothesize, and almost everything I'm going to tell you in today's class is a gigantic hypothesis begging to be tested by going into the field and looking for more data. That makes it all of this makes subjects that are so ill understood. I've had students who come, and then when they're actually being quite frank, they say, what good is archaeology? If you can't say anything in mathematics, I can say that 2 + 2 is 4, and 2 + 2 is going to be 4, no matter how you look at it or in which universe you're looking at it, it's going to be the same. But in archaeology, you keep on telling me that you don't really know. It is possible. It's a hypothesis. So what good is archaeology? Well, you could look at it that way, and if you were to look at it, I wouldn't blame you. I choose to look at it as much more different, in an entirely opposite way. The fact that we know so little about all of this means that we can make such a bigger impact in studying it and in trying to obtain more information. That makes it exciting for me. But I realize that some people just want certainty. If you want certainty, don't become an archaeologist, because archaeology is all about becoming slightly more certain, knowing a bit more than the previous generation, and hoping that the next generation will know a bit more than you. But the full certainty, no. Archaeology, if that's what you need, archaeology is not for you. So the question is it that Erectus is seeing opportunities elsewhere and it's exploiting them, or is it being pushed out of Africa, or is it a combination of both factors? Are we looking at a migration out of Africa, or are we looking at a whole set of migrations out of Africa for entirely different reasons over hundreds of thousands of years that are all being conflated into one as a result of our lack of chronological precision? I don't know the answer to that question, but those are the sorts of questions that you need to be trying to answer. Earthquake. How interesting. Oh, look at that. We might want to walk outside. Let's walk outside until this passes. That's a new one.
Yeah, that's a new one for sure.
I'm not seeing it all. It's the earthquake you were talking about, like day 2. 6.3.
You know,
Six.
like,
Yeah.
from here. Wait, what?
6.3. Where's the epicenter? I left my phone inside.
30 miles away.
Wow. Well, the question is how long do we wait out here? let me get my notes and we can continue here if you don't mind.
Northview.
Let's just continue here for a few minutes and eventually I'll take a vote to see if people want to go back in and we continue, or we call it a day, or we do the best we can. Okay, so the paleoanthropologist Midian Bellmaker of University of Tulsa has said, and I quote, that we need to change the question from the where, the what, and the when of the dispersal of Homo erectus to the why it was successful. And I think she has the right question here, that we need to try to think in terms, what, in a sense, what we're trying to do, and a lot of archaeology is exactly this, is reverse engineering. We know what happened. What we don't know is what made it possible for that to happen. So that's the why that we need to focus on. And the question is, again, there's two obvious possibilities as to the why, and they're not mutually exclusive. One is increases in cognition, and the other is increases in technology. And increases in cognition can be, in a sense, disposed of fairly quickly, or not disposed of. Disposed of seems to imply that we disregard it. We know that Homo erectus has a cranial capacity that is significantly enlarged vis-a-vis that of its immediate predecessors. We presume that there is a correlation between larger brains and larger intelligence. That presumption is generally proven correct in biology, but it's not a one-to-one basis. It's not that larger brains imply a greater intelligence, because if that were the case, Neanderthals would be more intelligent than we are. They had bigger brains than Homo sapiens sapiens. Brain is, of course, always, the size of the brain is, of course, always related to the size of the underlying body, undergirding body, so to say. And a lot of the issues of intelligence in the brain do not only have to do with size, but have to do with what happens in the specific areas of the brain and the convolutions of the brain and so on. Quite frankly, if you ask me, what do we know about erectus brains, other than they were somewhere in the 2 to 2.5 times bigger than those of its immediate predecessors, I cannot tell you anything. I cannot tell you anything about the structure and the inner structure of erectus brains as opposed to brains of other species. So cognition may be a factor, but I can't tell you how much of a factor. There's another factor, and that is technology. But the point I was trying to make, and that's what I want to talk a little bit now, but the point I was trying to make, or I'm going to talk a little bit later, but the point I was trying to make is that Bellmaker is right. The question is not what happened or where. All of those are important questions, but they are pedestrian questions. The real question, the one that is really important, is why did it happen? And there, as I said, there's two potential answers, cognition and technology. So the question is, why is Erectus, the first human ancestor, successful enough to be able to make this trek? And it's a big trek indeed. As I said, there's some recent, let's wait until they pass and then. There's some recent finds in the country of Georgia, in the Caucasus, showing the presence of Erectus fossils there by 1.6 million years ago. There's the ones that were found well over 140 years ago, or 130 years ago, in Indonesia, which initially were thought to be much, much later, were later redated to 1.1 million years ago and have now been redated to much earlier, 1.8 million years ago. Now, if the earliest Erectus fossils that have been documented in eastern Africa are 1.9 to 2 million years ago, it essentially means that relatively little time passed between Erectus developing in Africa and emerging from Africa and traversing to the Caucasus and eventually all the way to East Asia and into Indonesia. Indonesia, of course, is now an island, but in glaciated periods, it would have been connected to the Asian mainland. So in a sense, Indonesia is the easternmost part of the Asian mainland. We have to understand it. Now, from East Africa to Indonesia, that's a long way to go. But you have to realize that, of course, it's not, we can't conceptualize as in somebody realized, oh, let's go find greener pastures and there's something out there 10,000 kilometers away and that's where we're going. Of course, that's not the case. Anthropologists have documented the hunting and gathering behavior of modern, via ethnography, of modern hunting and gathering populations. And they have documented the ways in which these populations move around the countryside, looking after resources are exhausted in a particular area, they move to wherever else the resources have not been exhausted, and so on. In modern-day Africa, such populations move on average something in the order of 8-9 kilometers a year in search for greener pastures, so to say. And the movement of Erectus must have been, which almost certainly earned a living by hunting and gathering, or scavenging, as the case may be, it must be conceptualized in similar forms. So when you talk about, okay, they're in East Africa and 100,000 years later, give or take, they are in East Asia, and that's a long way. Think of it in terms of they're moving about 9 to 10 kilometers a year. That's all they're doing. But you do that every year for enough years, and in something like, it wouldn't take more than about 12,000 years to get from Nairobi, Kenya to Jakarta, Indonesia, at that particular rate. So essentially, it is well within the parameters of the chronologies that we have. A movement of that magnitude. So why did Erectus populations leave Africa? If we were in there right now, I'd be showing, is there any advertisement that is safe to go back in, or what are the advertisements saying? It's still, huh? Well, there's aftershocks. Shall we continue here with our slides or go back in? I'm happy to do whatever the majority wants to do.
I go back in. But...
Everybody's happy? If it starts shaking just a little, we come out again. Keep an eye on the slides. If it starts shaking, you will notice it with the slides. Yeah. Let me know if the slides are moving. Okay, so Elizabeth Brava. Okay. Elizabeth Brava from Yale University has tried to explain this question of why. guys, let's focus on this. Has tried to explain the question on why, and essentially she is saying that more likely than not, the environmental fluctuations of the Pleistocene, which essentially shifts, periodically shift for reasons that have to do with the axis of the rotation of the Earth between a glacial periods and interglacial periods. Glacial periods characterized, of course, by extreme cold, and interglacial periods characterized by much warmer climates. We are right now in an interglacial period. She argues that this is what is acting as some sort of a pump, so to say, propelling these populations in a series of movements out of Africa. The question of why brings us to the issue of fire, and I want to spend a little bit of time on the issue of fire. One thing that is very clear, there are erectus populations in Europe, at Atapuerca Cave in Spain, if I recall correctly, dated to 900,000 years ago. Some earlier ones have just been discovered. So Erectus enters Europe fairly early. Erectus is in the Caucasus earlier still. Erectus is in East Asia earlier still. And surely it must have moved through a variety of temperate climates. And it had to, it could not have lived in Europe. It could not have gotten to East Asia without traversing temperate climates. So a priori, one should presume that, that one part of the question of why that Bellmaker asked has to do with a new technology. And in fact, the earliest evidence that we have for the controlled use of fire comes in association with Homo erectus sites. The earliest evidence we have for a hearth area, archaeologically determined a hearth area that is more or less decently dated, dates to about 500,000 years in South Africa with a site associated with Homo erectus. But the presumption is that Homo erectus must have been able to control fire much earlier than that, because in a sense, the expansion of Homo erectus across the world is itself proxy data for control over fire. And it could very well be that the expansion of erectus brains, the dramatic blow up of erectus brains to 2.5 times those of its immediate predecessors, are also the result of this human technology of being able to control fire. Fire is really important. Fire is, of course, a technology, and then that makes it into a tool. Fire offers warmth. It allows you to create a microenvironment. And without that, as I said, you can't conceptualize colonizing the temperate areas of the world as erectus populations did. Additionally, fire provides an easy and exponentially more effective way of earning a living. And in particular, fire provides a much more effective way of hunting game. Instead of hunting individual animals, you can actually set a whole savanna on fire and put some hunters in the place where the logical geographical place where animals would concentrate, and kill them by the dozen as opposed to individually. So by waiting at choke points and setting whole landscapes on fire, anybody who controls fire could have hunted very exponentially more effectively than anybody who did not control fire. Fire is also a technology that helps us make other technology. One of the characteristics of erectus, as I will talk about in a second, is a fairly advanced cutting-edge technology, the Acheulean hand axes. I'll show you that in a second. If you want to craft a very difficult to craft a flint tool, you do that in part by heating it to a certain temperature so that it will crack in specific ways as opposed to others. So a fire helps you make other hunting technologies. In the case of flint, which is the one that we find the most. But presumably, fire would also allow you, you can heat the wooden lances, heat the ends of wooden lances in order to harden them, and so on. So we have precious little, if any, evidence of the use of wooden tools in association with erectus, but that, of course, is an accident of discovery because wood is organic and is very unlikely to be preserved. But the fire helps you make all the tools and all the technology that helps you become a better hunter. Equally important, and perhaps even more importantly, the light of fires at night offers protection from predators. Without being able to make a fire, you are essentially at the mercy of animals that are individually more powerful than you are. If you are able to light a fire, those animals will leave you alone. So essentially, it's a technology that allows you that gives you a leg up over other predators that prey on you. And the last point I want to make about fire, and this is by far the most important point, fire allows for the cooking of food. If you control fire, fire, of course, occurs in nature. Every time there's a lightning strike or so on, you get fires. So there's fires in nature all the time. The issue is being able to create a fire on your own, the controlled use of fire. And if you want to cook, you have to be able to control the use of fire. And cooking makes a really, really, really big difference. So cooking, in a sense, is allowed by a human technology, and that is the control of fire. Cooking destroys many viruses and bacteria in meat and many toxins in vegetable foods, allowing people to use a much wider range of foods in their diet than they could have if they had no control over fire, and allowing humans to use those foods for much longer. If you do not control fire, essentially your meat is going to spoil relatively quickly. If you cook that meat, it's going to spoil much more slowly. You can use it for much longer. So you can extract a lot more energy from it. The amount of spoiled food and the amount of disease that eating spoiled food would have caused in human populations is greatly reduced by fire. The importance, fire is essentially something that anthropologists call a cultural universal. A cultural universal is a characteristic that every human society that has been documented has. Every human society that has been documented uses some type of shelter, for instance. That's a cultural universal. Every human society that has ever been documented by anthropologists has the controlled use of fire. Were there human societies that did not have the controlled use of fire? Of course there were, without any question. And why aren't there any now? Because they were outcompeted by those. They either, populations in their vicinity that achieved the technology of being able to control fire, either outcompeted them and eradicated them, or those that did not have that technology emulated their neighbors and acquired it. The end result is that every human, it is now a cultural universal, every human society that has ever been documented, from the simplest to the most complex, has the controlled use of fire. There are other cultural universals that cross-cut culture. Emotions are another one of them. You know exactly what that young lady is feeling, whether or not you speak their language, and you know exactly what those young boys are feeling, whether or not you speak their language. That is, emotions are another cultural universal. So is fire, for that matter. The argument for the importance of fire has been made rather explicitly by Richard Wrangham, an anthropologist from Harvard University, in a book published about 10 years ago entitled Catching Fire: How Cooking Made Us Human. In other words, his argument is that cooking a human technology made possible by the cooking, something made possible by the human technology of a controlled use of fire, made us human. That's a big statement. I'll come back to that statement. We are what we are because of that technology that we developed. And that's a major philosophical statement. I'll come back to it later on. But first, let me tell you what Wrangham actually says. His argument is that the importance of cooking cooking food for human evolution can hardly be overestimated. As I said, he's made that in print in that book. There is an interview with Richard Wrangham in one of your readings. Please read it. In event, Wrangham argues that cooking is what made us humans, what made humans into such an unusually successful animal. Wrangham knows that cooking alters food in a variety of ways. First, it breaks starch molecules into more easily digestible fragments. In other words, that it is easier to digest food that is cooked than food that is uncooked because it breaks the starch. It makes it easy to digest. Why should you care? Well, the easier it is to digest, the less energy your body uses in digesting it, and the more efficient and the greater the amount of energy that it gets from the digestion. So essentially, you're spending less energy in order to gain energy. Second, fire breaks down protein molecules so that digestive enzymes in our stomachs and intestines can break amino acids also more easily. Again, it makes it easier for us to extract amino acids as compared to uncooked food. And lastly, heat physically softens many foods, and that too makes them easier to digest, saving the body many calories digesting cooked food as opposed to raw, uncooked food. Specifically, Wrangham notes that cooking increases the share of food that is digested in a particular part of your intestines. So it changes how much of your food is going to be digested between the stomach and the small intestine, and anything that is digested in the small intestine, at that point, you increase the amount of absorption between 50 and 95%. And cooking makes it possible for digestion in the small intestine as opposed to the stomach or the large intestine. Cooking is also important because it affects how soft food is. And he made an experiment. He essentially had a bunch of rats, and he fed them on soft food that had a particular amount of protein content. And he fed another batch of the very same rats with hard food, the same type of food, but much, much harder, with the same amount of protein content. And he found that after 26 weeks, the rats fed on soft food, both foods, remember, have the exact same amount of protein content, where the ones fed on soft food were 30% larger. Namely, they use that much less energy extracting energy from the food that they ate. So they had a much lower cost of digestion. All of this is rather important because, of course, one of the characteristics of humans as compared to other primates and to very early human ancestors is that we have unusually large brains for our body. Chimpanzees have more or less the same body mass that we have, a little bit more perhaps, and have a cranial capacity which is about 1/3 of us. So in a sense, humans have an unusually well-developed brain, and that is a wonder and a curse. A curse in many ways, but it may be a biological curse for reasons I will explain in a second. So body for body, our brains are on average 3 times bigger than those of chimps and gorillas. If you, in the case of gorillas, of course, if you account for the biological differences in body mass. So essentially, we are our brains are 3 times larger than those of our cousins in about the same amount of time. Remember, we have all chimps, gorillas, and us have been developing side by side at about at the same time, and yet our brains, and not theirs, are 3 times larger, and the question is why. And for Wrenham, the answer to that question, to the why, is a human technology, namely fire, and in particular the use of fire for cooking. Brains, as I said before, I think I mentioned this, are very expensive organs. This very big brain of ours uses 20% of our energy. It occupies 2% of the body mass of your body by weight. Your brain is about 2% of the weight of your body. This is an average. People vary. But it's about 2%, and yet it uses 20% of the energy you consume. Actually, it's between 18 and 20%. But in any event, you get my point. It is an expensive, energetically expensive organ. Large brain, therefore, can only survive in situations when there is a stable, high energy food supply, protein-rich, to feed it. It is the evolution of our brains absent a high energy, protein-rich diet is simply hard to conceptualize. And the ability to acquire such a high-energy, protein-rich diet, if you eat cooked foods, is much, much greater than the possibility of doing so if you do not. It's as simple as that. So when you actually look at the fact that brains are growing disproportionately higher at the time of Homo erectus, and Homo erectus is the first that one may assume from early on, from the dispersion of erectus across the world, control fire, and then later on in the erectus evolution we can actually demonstrate it archaeologically. If you assume that, then it's not difficult to put 2 and 2 together and suspect that that which makes us human, I think most of us would agree that our big brains are part of the equation to the answer of this question, what is it to be human? It's hard to conceptualize those big brains absent the control of fire. And the point here is a rather important one. The anthropologist Timothy Taylor published a book about 10 years ago. It's called The Artificial Ape. Before I do that, Jared Diamond, do people know that recognize that name? He's a very well-known anthropologist from UCLA who wrote Guns, Germs, and Steel, Collapse, and so on. His first book was entitled The Third Chimpanzee. And who is this third chimpanzee? It's us. It's a book about humans. But by calling it The Third Chimpanzee, he was at the very same time emphasizing how similar biologically, genetically we were to our closest cousins, and at the very same time how utterly different we are, is how different that 1.4%, how much that 1.4% genetic percent difference matters. So modeled on this, Timothy Taylor talks about the artificial ape. And who is the artificial ape? That's us. We are the artificial ape. Artificial in what way? His point is that that we tend, I suspect, I don't know. Let me ask the question. Human evolution, biological human evolution, are you evolving? You, now. Yeah, you said no. You said no. And I suspect that if I stop 100 people in the street, they would say no. You're wrong. We are evolving as we speak, doing so slowly that you're not seeing it. But the bottom line is that we continue, our bodies, our genetic components, our bodies, our biology continues to change. We continue to adapt to everything in the environment. The rules of biology did not stop with Homo sapiens sapiens and did not stop with the 21st century. They continue. The issue is, do you have enough distance in time to actually see the change. And if you did, you probably would. But let me give you a couple of examples which are going to illustrate the point that Mr. Taylor is making. Glasses. You see, I have reading glasses, I have normal glasses, and so on. Without glasses, I could not see much. A high proportion of the modern populations in the Western world, I say Western world because that's where most of the studies that I'm thinking of were made, but I presume that this applies across the world now, are quite nearsighted. One presumes that the human ancestors in antiquity would not have been so nearsighted. That doesn't mean that they were that nearsighted individuals were not born to those populations. That probably just meant that nearsighted individuals were more likely to not see clearly, fall on a hole in the ground that they failed to miss, break a leg, and die out of an infection that they could not control because they had no antibiotics, and never reach reproductive age. So essentially, in a normal population that lives on average to age 20 or 22 and dies, the likelihood that nearsighted individuals would reach a reproductive age was greatly diminished in antiquity. Now, that likelihood that the likelihood that I will drop on a hole and break a leg and die and not reach reproductive age has been greatly diminished by the invention sometime in the in the late Middle Ages in one of the Italian city-states, probably Florence, of monocles, or glasses, that corrected for your eyesight, and eventually the invention of the glasses like we see now, which took place about 15th, 16th century AD in what is today Holland. Once you do that, and this is very clearly a human technology, this is a human way of correcting, once you do that, the likelihood that I will, if these things had not existed, and if we had no antibiotics and no hospitals and all of that, the likelihood that I would never have reached reproductive age is much, much higher than the likelihood than now. Now I am likely, by means of this this technology, this artificial technology, I'm much more likely to see the hole, not fall in it, not break my leg, and not die, and therefore I'm much more likely to live and reproduce. In other words, by means of this technology, we have now a population of individuals that can perfectly well survive and thrive, even though they have a biological deficiency in their ability to see the environment. You see the point I'm trying to make? So now, give me 2 seconds. So the point I'm trying to make is that if you had a population of 100 individuals, say erectus, and you had a population of 100 individuals, say us right now, the likelihood that that population of 100 erectus individuals would have had a high number of them would have been nearsighted was very low. The likelihood that a large proportion of individuals, of modern individuals, would be nearsighted is much, much higher. In other words, this human technology has altered the relative proportions of nearsightedness in human populations, has altered the biology of human populations. We continue to evolve. And the point I was trying to make is that what Branham is saying is that that human technology, control over fire, and what he gave us, which is cooking, essentially affected and determined, made possible the exponential increase in brain size that we observe in humans, but not in any of the other closely related species at the very same time. So this is what Taylor means by the artificial ape. We have, our biology, ourselves, have been transformed by our own technologies. So we are our own makers, is what he's trying to say. we make ourselves by the technologies we have. Sounds like an outrageous argument, but actually it's a very common argument. Surely you know about Nicholas Carr, that I think I may have mentioned early on in this class, that wonderful article of his, Is Google Making Us Stupid? Which if you haven't seen it, Google it and read it, because it's a brilliant article. It appeared 10, 12 years ago in the Atlantic magazine, which is incidentally a very, very good magazine to read. It has all sorts of thought-provoking things. And in that article, what essentially he says, he's trying to answer the question, is it making us stupid? And his answer is, yes, in some ways it's making us stupid. In other ways, it's making us a lot sharper. It's making us stupid because we tend to not go in depth anymore. But it's allowing us to see all sorts of connections between the things. Browsers, he says, mean that we tend to not penetrate as deeply into any one subject as we used to do. But it allows us to flit from one subject to the other very, very easily and see connections that we wouldn't have seen otherwise, that we would have missed otherwise. And his conclusion is that whether it's making us stupid or making us sharper depends, of course, on where you're coming from and which one of these do you think is more useful for the 21st century, which one of these abilities is using. But his conclusion is that it's changing the way humans cognize the world. And in so doing is changing human cognition and human biology. So this concept that we make ourselves, that human technologies change us biologically, that human technologies change us socially. I mean, Marx said that 150, 200 years ago already. Give us a break. Everybody takes this as a given. That human technologies change us biologically. It's been said a number of times, fairly recently, and in different fields and from different angles, and there is quite a bit to it. I mean, you don't have to go that far. Just think of the world, human populations without this technology. Would we have the same proportion of nearsighted individuals as a proportion of the total population if we didn't have this technology? And the answer is no. It changed. It selected for the survival of individuals that otherwise would not have been selected for. And in so doing, it changed us. It changed our biology. By our biology, I don't mean my biology, I mean the average of the biology of any given society. So let me leave it there, and we'll continue on this subject in the next class.